Hi Calc and welcome to 2.2. When you look here, we're going to be doing a lot with actually quadratics. So let's see what we know. Make sure you got 2.2 notes out. I also would like you to have Desmos loaded up. If you go to your Google and you search Desmos, that's a free graphing calculator. It will come up and you're going to actually type in your parent graphs so you see what they look like and make different connections. Thanks, and let's get moving. Okay, when you look here, we have vertex form. And then how does that move? So vertex form, you can see the vertex in the equation. We get there by completing the square quite often. We're going to graph from standard form. So can you read the vertex, the x and the y intersect? And they're going to do translations where they move up and down on non-quadratic, even though they are the same. So are the same type of move. Let's see what you remember. Okay, A represents what? I'm hoping you tell me it's two things. If it's negative, it's a reflection. If A is greater than 1, it is a stretch, or the absolute value of A, I should say. And if the absolute value of A is less than 1, then it is a compression. So it works similar to a slope, remember? H is the x value of the vertex. It's always opposite of the sign that you see in the equation. And the k is the y value of the vertex. All right, let's go down. So now, on your Desmos, type in y equals x squared. So when you typed in y equals x squared, you should have went through 0, 0, 1, and negative 1, and graphed in this parabola. Okay, this is known as our parent graph. Now, type in 2x squared. You should notice that instead of going through up 1 over 1, it now goes up 2 over 1. Just on the very first one, it no longer goes up 2 over 1. It would take the 4 here and multiply it by 2 and go up to 8 for the next one. So it goes through here and here if you want to graph more than 3 points. So if you notice, it gets very, oh, that's a terrible graph. It stretches it out. Okay, now do the negative 3x. I'm hoping you notice instead of going up, it now goes down 3 to the left and to the right 1. It still has not moved from the origin. And that is still called a stretch because it stretched it out. Okay, now do your x plus 3, your x minus 4. So this was stretches. Type them in. You should notice that your parent graph, I'll draw it back on just in case you don't see it. So here's your parent. It goes through 1, 1 and negative 1, 1. The plus 3 moved to the entire graph to the left 3. So it still has the exact same stretch. If you notice, the shape did not change. So it still goes up 1, right 1, and up 1, left 1. The negative 4 moved it to the plus 4, still up 1, right 1, and left 1. And there are your two graphs. So this was the x minus 4 squared. This was the x plus 3 squared. And this is your parent, your x squared. So these move opposite way, left and right. So this guy went left and this guy moved right. Okay, so try this one, the plus 5 and the minus 1. So let's draw in your parent again. So we start at 0, 0, up 1, right and left 1, parent. And this time the 5 made it go up 5. So you started here, but you still had the same shape. It went up 1, right 1 from 5. So it went up 1, right 1, and up 1, left 1. Shape did not change. The entire parabola just moved up. The negative 1 took the entire parabola and moved it down. Still the exact same shape, just moved. All right, let's put it all together. Try it without decimals this time. So you should have recognized that this here moved left 3 and down 5. So my vertex is -3, -5. My stretch is 4, or 4/1, however you would like to write it. So we go -3, -5, and I put my vertex. Then the stretch is 4/1, so I know I go up 4/1 to the left and to the right since it is a squared. And we draw in our new parabola. This exact thing works on all of them, no matter what. So if this says take the function and add 3, this wants to move the entire thing up 3. So it's going to go up 1, 2, 3. Instead of being at -1 now, it's going to be at 2. Let's move my, okay. Is that at half, at 2, kinda? We'll do that way. This one here is at -1/2, 2, and then 1 goes through. There we go. And now, if you look, it goes up and down and up and down. So we move the entire graph up 3. How does it change if I move it in here? I hope you're saying it moves the entire graph left 3. Remember, opposite sign. So we go left 3, and this is where we're going to start. If I can get that on the graph. And then we're going to put in our 2 points that go down and up. And here is, if it draws, your x plus 3 graph. Now, what do you think the -2 does to my entire graph? I hope you said it is going to start where it is, but instead of going up, it's now going to go down. So instead of going down at a half, it's going to go up. Still going to go through here. Same option here and here. And then there we go. Fourth root graph is just going to be facing down with a stretch of 2. All right, so now how do we get that stretch in there is the next part. So if we look at 1, it's at 0, so that's still at 0, but a half times 2 is 1. So the stretch is actually going to go here and go up to 1, back down, and up to 1 and back down. I cannot draw to save my life. Hopefully you got that. Let's do a table just to make sure. So we're going to take our regular values. Let's look at -1, -1/2, 0, +1/2, and 1. So when you plug in -1, you're at 0, so that's still 0. Your 0 is still 0, and still is your 1. It's these that change. So at -1/2, I'm at -1/2. All right, so if I take -1/2 times -2, I'm going to get a +1. Hopefully. And if I take -1/2 again, 1/2 is still at -1/2, times -2, I'm also going to get a +1. So that's where that came from. You're taking the y values, so the -1/2 times the -2. The y value of this point is also -1/2 times -2. And this is how we get the ones, which is what I tried to graph, but was not very successful. I hope you did better. All right, pause and try yours. Now I'm hoping you remember that this here is actually a flip over the y. So when x is 0, I still have 0, but when x is 1, it's undefined. But at -1, so we have this, the square root of minus a -1, well, that's just the square root of 1, which is 1. And then if we do the same with 4, the square root of -4 is really the square root of 4, which is 2. This guy reflected over the y-axis. All right, so now we're going to take this reflection and we're going to move it. So if we look here, this here's kind of tricky. It really means -x plus 5, which really means -x minus 5. you need the negative out by itself. So we have the square root of this plus 3 all times 2. So I'm taking my original negative x, I'm going x minus 5, which means I am going to move to the right 5. So we're going to go to the right 5, 1, 2, 3, 4, 5. We're going to go up 3, and that is our starting point of our parabola. And then the 2 is going to stretch it 2. So instead of going up 1 over 1, I'm going to go up 2 over 1. And that is your new graph. All right, I hope you did well. If you're having trouble, do the stretch first and then do the move after you stretch. Completing the square. I'm hoping you remember that's half the middle term squared, but we have rules. Remember the number in front of x has to be 1, and the numbers behind the linear terms have to be gone. So there's a couple of ways to do this, and the book does it a different way than I think you've been taught, but I really liked it. So let's do this. Let's move the 1 over to the y, just so he's kind of out of the way. Okay, now I have these two terms. I'm going to factor out the 2, so I get the x squared by itself. So I have x squared minus 3x plus this blank that I need to fill in. But I also have to add it over here. So now I take half of 3, and we square it, and we get 9/4. And we need to add it to both sides of the equation. Well, I know that 4/4 plus 9/4 is 13/4. That's a plus. 13/4 is equal to, oh, I just messed that up. And I was hoping, and you're not even here for me to tell you to yell at me. Okay, what we did wrong, did anybody catch it? At least I hope you did. Is this is not really 9/4 that we're adding. I think we need to make this bigger. We have y plus 1, that's a 1, plus our blank. And our blank is 9/4, but I have to multiply it by 2, which gives me 9/2 is what I'm adding to the side. So 9/2 plus 1 is 11/2. So now we have y plus 11/2 equals 2 times my completed square, which is x minus 3/2 squared. Let's get rid of this extra stuff in the middle here. We're close to vertex form. Now all we need to do is bring the 11/2 back over. So y equals 2 times x minus 3/2 squared minus 11/2. Now when we look at this, I know I have a stretch because it's 2, it's greater than 1. So I'm going to have a stretch of 2. It's not going to reflect because it's not negative. The y-intercept is actually from the beginning, which was this -1. All right, so I know my y-intercept. So that's when x is 0. Y is -1 from up here because you plug in the zeros for the x's. So that's always from the original. So 1 point on my graph is going to be 0, -1. Now I have to look here. My vertex right here is 1.5 because it's opposite sign, and a -5.5. So let's graph that. Let's go to 1.5 and down 5.5. 1.5 down 5.5. And there's my vertex. I know my vertex is symmetrical. So if this is 1.5 away from here, I go 1.5 away from here. And there's my other side. And I can now draw in my, ooh, I missed it. Bad. Let's try it one more time. Hopefully you're doing better than me. I almost feel like I need to recalibrate this, but I don't think I know how. So it goes like so and like so. That's better. All right. Hope you're doing well with your questions. Try yours. Pause and do it. All right, I hope you did a good job. Your first step should have been to put the 1 to the other side and add your blank. You took half the middle term and you squared it, which gave you 1/9. But you're taking 1/9 times 3 and adding it to the other side, which is 1/3. So now you've completed your square. You subtract the 4/3 to the other side. So here is the vertex of your parabola, negative 1/3, negative 4/3, with a stretch of 3. So we go to negative 1/3, down negative 4/3, then we go up 3 over 1 and draw in our parabola. All right, just a few reminders. This is the leading term. It tells us how the parabola opens. If A is positive, it's up. If A is negative, it's down. Squared means a parabola. C is your y-intercept. When you let this equal to 0, that is your x-intercepts or your roots. The vertex is opposite of B over 2A for the x value. Then you plug that in to find your y. Axis of symmetry is also the opposite of B over 2A. Okay, let's see if we remember what we're doing here. So let's factor. First, I need to know what A is. Well, A is negative 4. This tells me that the parabola opens down with a stretch of 4, so it's going this direction. X, our y-intercept is the y value, so this is 0, 5. And now we try to factor this. Well, when we try to factor, we get negative 20x squared. There are no factors of 20x squared. Hang on. So 20x squared is negative 10x plus 2x. That adds to negative 8, multiplies to negative 20. Bring down your first one and your last. Group. Take out what they have in common. I'm going to put a 1 here just so we don't get messed up. So now we've got 2x plus 5 and negative 2x plus 1. Well, those, so we have x equals a negative 5 halves and x equals a positive 1 half. Those are roots of my function, so that tells me where it crosses the x-axis. So it crosses at 1 half, and negative 5 halves is negative 2.5. And I know we could find the middle, but to find the vertex the other way is the opposite of b over 2a, and we just need to practice a little bit. So the opposite of b would be positive 8 over 2 times negative 4, which equals negative 1. Now you take the negative 1 and you plug it back into the original problem. I'm running out of room here. I'm going to go over here. So we're going to take negative 1 and plug it back into the original. And you get negative 4 plus 8 plus 5, which equals 9. So your vertex is negative 1 comma 9. So we go to negative 1, we go up to 9, and this is my vertex, which makes sense. I knew it was negative and needed to open down, and we can draw in our parabola. At negative 1 is also your axis of symmetry. So your vertex is negative 1, 9. Axis of symmetry is always x equals, and that's negative 1. It's the x value of your vertex. Okay, pause and do yours. Okay, first thing you should have done is say, hey, does that factor? And this was a nice factor this time. So it's x minus 5, x plus 1. So I know x equals 5 and x equals negative 1. Okay, so now we've got our 1 or negative 1. We have our 2, which is our axis of symmetry. We're going to plug in our 2 and find where this actually crosses for our vertex. If you heard the phone ring in the background, that was my mom and dad calling, so I apologize. So let's keep going. We have 4 minus 8 minus 5. So we have negative 9. So we're going to go to 2, negative 9, which is down here. This is my vertex, and now we can draw in our parabola. All right, I hope you did well on that. And let's continue. If you notice, right here, this was positive, so our parabola is facing up, and that's a one-to-one function. So we didn't even have to do a whole lot because that 1 is our A. Quadratic formula. And you're not even here to sing with me. How sad. So let's remember x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I hope you sang it along, even though you didn't have to. All right, quadratic formula to find the x-intercepts. So this is just another function, another way of doing it. So we say x is equal to the opposite of b, which is negative 2, plus or minus the square root of b squared, 4 minus 4. A is 3. C is negative 1. Don't forget that. All over 2a. Okay? Let's plug that in there. Okay, when you type that in, you should have got 1/3, which is right here, and negative 1. Your vertex, you know, is the opposite of b over 2a. So it's the negative 2 over 6, which is the negative 1/3. So we're going to go to negative 1/3 and draw in our axis of symmetry. Plug that into the original function. Okay, when you plugged it into the original function, which I did over here, you should have gotten a negative 4/3. So we have negative 1/3, negative 4/3. So we are down here for our vertex. We know our y-intercept is the last value. So our y-intercept is negative 1. So negative 1 is where our y-intercept is, and we can mirror that if we would like. And we can draw in our parabola, which happens to be fairly thin. Another method. All right, let's look at this. We have application. So this is profit and loss. Remember, revenue versus cost. And we know that profit is equal to revenue minus cost. And we've already learned that. So right now, let's graph these two functions. The break-even point is going to be where they meet, correct? So when we graph this, we're going to look at minus x squared. Let's go here. 30x. When I graph this, I'm going to factor out a negative x, which gives me x minus 30. And we're going to cross at, whoops, I didn't need the parentheses there, at x equals 30. And x equals 0. So we're going to have 0 here. We're going to have 30 here. We're going to know, if you remember, your vertex is always halfway. So 0 and 30, it's fairly easy to find this. My axis of symmetry is at 15. So let's plug that into my original problem. So I'm going to have minus 15 squared plus 30 times 15, which is 225. So we're going to graph this. We're going up to 225, and that's going to be roughly right there. And this is sorta, if I could draw it better, life would be good. My parabola for revenue. Okay, cost is very simply just a line. Starts at 100, goes up 5 over 1. I can't go up 5 here though, because I don't have 5. So if I go up, let's see, if we go 5 over 1, how about 500 over 100? So I'm going to go up. Nope, can't go that far either. It's too high up. So let's do, how about 50 over 10? Can I do 50 over 10? We can do 50 over 10. So we can go up 50 over 10 and draw our line. All right. So we know we got 2 break-even points here. One here and one here. Our max is going to be where we're farthest away from each other. It's going to be our max revenue. So not our max profit, I'm sorry. So to find the break-even points, I'm going to take negative x squared plus 30 over x, because I can't graph, equals 5x plus 100. Set that equal to 0. So we have negative x squared, subtract the 5x. So plus 25x, subtract the 100, equals 0. factors of 100 that equal 25. Okay, let's factor out that negative to make my life a little easier. So we got x squared minus 25x plus 100. I know that's going to factor into x minus 5 and x minus 20. 5 times 20 is 100, subtracts to 25. So where x equals 5 and x equals 20 are my break-even points, which I didn't graph too awfully bad. If you look here, we're at 5 and we're at 20. Now, to find that actual point, it doesn't matter if I plug it into this revenue or the cost, it will be the same place. So we're going to pick cost because that's easier. So my first point is going to be 5 times 5 plus 100, so 125. So point is 5 comma 125. Now when we plug in the 20, we'll have 5 times 20 plus 100. So that's 100 plus 100, which is 200. Ooh, I'm a little bit off. Not terribly. So that is going to be 20 comma 200. And those are the two break-even points for my graph. Maximum revenue, we know is opposite of B over 2A. We also know that's already 15 because we found it earlier. We knew it was halfway, which is fine. So if we can do maximum revenue, it's at this point up here. And we plugged in the 15. We got 225. So our max revenue is 225. Max profit is revenue minus cost. So we're going to take these two and subtract them. We're going to take minus x squared plus 30x minus my cost, which is 5x plus 100. So now we have negative x squared plus 30x minus 5x minus 100. So this time, oops, we're going to get, I'm going to run out of room, minus x squared plus 25x minus 100, which is what we already did up here when we did our break-even points. So I know that this is going to equal to my max profit. So this here is like a combination or composition of those two functions. So now I need to find, its vertex. So in other words, I'm going to do the same thing I did up here, but now I'm going to look for the vertex of just this function. So we're going to take the negative out, and we have x squared minus 25x plus 100, and we know that that factors. Oh, actually, I don't either want to do that. I'm going to change my mind. We're going to do this easier. We're going to do opposite of b over 2a, just so it's a little faster. So the opposite of b is negative 25 over 2a, which would be a negative 2. So this means we are at 12.5 is where my max profit happens. We're going to put this 12.5 back into my equation right here. So I am so out of room. I'm so sorry, children. So this is equal to, can I go down just a little and have a little bit? Okay. Now, I hope you paused and you did your work. So when you went through and you were doing this, whoops, you should have made a no, don't know chart. So you were, oh, I lost it. Hang on. Here we go. A no, don't know chart. So when you're reading through, the company charged $600. So this is what we know for, and it attracts 1,000 people. So I know at 600 I get 1,000. So if it does that, this is my revenue. Okay, but for each 20 decrease in fee, so if I subtract 620 from the 600, so it goes down 20, for every time I do this, so x is how many times I subtract 20, I add an additional 100 people. So I drop 20, but I add 100 people. So I dropped 20, however many times I do that, and I add 100 for the same number of times I do that. Now you do your distribution, and you get your formula. Now I need to know what should the company charge to maximize their revenue. So to maximize their revenue, you have to do the opposite of B over 2A. So now you've got a negative 40,000 over a negative 2,000. So you're going to get 20 when you do this, and they should charge $20. I hope you did well. Good luck on your homework. Make sure you're posting questions. Sorry about the long video. Okay, I realized I made a mistake. So not only do you have a long video, I can't multiply. So when you divide this here, you actually get 10, correct? So 10 is where we're at. That's the opposite of BOT. That's my X. So to find what I should charge, I need to plug this in. So we're going to plug this back into our original. So we're going to take our negative 2,000, whoops, times 10 squared plus your 40,000 times 10 minus your, or plus your 600,000. And when you do that, your answer is 800,000, and that's their max profit. All right, their max profit occurs at 10 reductions. Okay, good luck. So that means they should charge, let's look, 600 minus 20 times 10, which means they should charge $400 per person. So at $400 per person, they will make $800,000. That will be their max profit. All right, now good luck and keep going. Thank you.